It will not work if the system has infinitely many solutions and if the system has no solutions. The calculator method, the RREF, will not change this matrix into a simple one that gives us X, Y, and Z. It will not if the system has infinitely many solutions or no solutions. It will only work if it has one triple ordered pair as solution. Okay, so let's choose one more and go through the same steps with the calculator. And now it doesn't matter what we pick, as long as there is a solution. It will not take us more than a minute. The whole thing, not 3 pages. And now you can choose anything. Now, all these systems need to be prepped. They're not prepped. I cannot have parentheses and the X in front or 2 in front or X and Y on both sides. They have to be rearranged. But they will, once we rearrange them like this, then it's in a, the solution will be in a blink. So let's choose another one and then go through the matrix step by step. Again.
Can we do 14?
Yes, perfect. It doesn't matter, whichever you pick, it's fine. 14, you said. Okay, so in 14, we have x plus 3y plus 5z equals 20, y minus 4z equals negative 16, and 3x minus 2y plus 9z equals 36. I'm going to directly write the augmented matrix. It's the one that we are going to have to put in the calculator. The system is arranged correctly. I don't have to rearrange anything. I don't have to do anything. It doesn't need any prep. So 20, negative 16, and 36. 1, 0, 3. 3, 1, negative 2. 3, 1, negative 2. 5, negative 4, 9. This is it. Let's enter it in the graphing calculator. So go to second and matrix. Select matrix A. I'm sorry. I didn't mean to do that. Edit. Edit matrix A because it's already 3 by 4 for us. Careful. 1, enter. 3, enter. 5, enter. And 20, enter. And always check, make sure that these are the coefficients. And then a 0, 1, 0, 1, negative 4, and negative 16. And then 3, negative 2, 9, and 36. Okay, checking again. 1, 3, 5, 20, correct. 0, 1, negative 4, negative 16, correct. 3, negative 2, 9, 36. Perfect. Get out of there with second and quit. You can already recall this if you already did that. And when I hit enter, it should look like this: 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, and some numbers in the right column. Nothing else in the left, but 3 numbers in the far right column. Okay, can anyone tell us how much is X, how much is Y, how much is Z? What is the ordered triple?
X is 0, Y 0.
And Z is 4.
And Z is 1.
That's it. Done. In a blink. Is it true? I don't know. No. Now we'll know. 5 times 4, correct. Negative 4 times 4, correct. 9 times 4, correct. Yes. Of course, you can use the same method on a 2 by 2. You can check. You can create the augmented matrix for a 2 by 2 as well, not but 3 by 3. But 2 by 2s are not difficult. Okay, I like to look at a word problem here. The sum of 3 numbers, la la la. The following is known about 3 numbers, la la la. So these word problems will convert. We will have to convert them into a system of 3 by 3, and then solve. And you can solve the system any way you like. So let's pick a problem, convert it into a system, and solve the system. Anyone?
23.
Okay, let's start with 23. Perfect. It's a lot of writing in these problems, but as you see, not terribly difficult. Only that problem, which we needed to see one like this. No, 10 was required steps. Okay, the sum of 3 numbers is 16. Can anyone give us an equation that signifies the sum of 3 numbers equals 16?
X plus Y plus Z equals 16.
Done. Excellent. Moving on. Normally, every sentence will discover an equation for us. Sorry about that. Okay, so the second, the sum of twice the first number, the sum of twice the first number, the sum of twice the first number, and let's move on. 3 times the second, and 4 times the third is, which is the equal symbol, 46. The sum of twice the first, 3 times the second, and 4 times the third is 46. We need a third equation. The difference between 5 times the first number and the second number is 31. The difference between 5 times the first number and the second number is 31. Good. The augmented matrix. 16, 46, 31. 1, 2, 5. 1, 3, negative 1. 1, 4, 0. Done. I'm going to use the same matrix again and edit it again. So 1, enter, 1, 1, and 16, 2, 3, 4, 46, 5, -1, 0, 31. Get out of there with second and quit. And of course, I'm just gonna copy the previous entry. I have to get the exact same thing. All these on the one on the diagonal, everything else 0, and the column of answers. Can anyone give us X, Y, and Z? X, Y, and Z?
X is 7, Y is 4, Z is 5.
Perfect. Is it true? I have no clue. But I don't need anybody to tell me whether it's correct or not. I'll do it myself. 7 plus 4, 11. 11 plus 5, 16. Correct. 14 plus 12 plus 20. Indeed, 46. 35 minus 4. Yes. Any questions? Any questions? Okay. Do we need more examples?
Can you just show us how to do it on the calculator one more time?
Yes.
And get to the one part?
Yes. So with your permission, I'm going to record this. Is that okay?
Yes.
So let me, because I'm not posting it anywhere but in the course, but I still wanted to hide your names, so they're hidden. Okay, so let me record. I think I'd like to record one a different problem, so it's all from scratch. Is that okay?
Yeah, that's fine.
Okay. So let me choose a problem before I click. Just any system, correct?
Yes.
Okay, so let me choose another system. Okay. Okay, so we go to second and matrix, and we go to edit, and we press enter, and we first have to enter 3 by 4. 3 enter, 4 enter, which gives us the size of the matrix, meaning 3 rows and 4 columns. And now I'm entering the coefficients of the system. 1, -1, and 3, and the free term is 8. Then 3, and then 1, and then -2, and the free term is -2. And the next one is 2, and then it's 4, and then it's 1, and then it's 0. After that, I go to second and quit, get out of that system, of that window. And then I go to, again, to second and matrix, but this time I choose the math. I'm trying to do math with the matrix. And scroll up to B, R, R, E, F. Press enter. Now go to second and matrix, because you want to call matrix A. Close the parenthesis. And when we hit enter, we will get a reduced echelon by row, row reduced echelon matrix, in which the coefficients, there are the free terms, 1, -1, and 2, represent x equals 1, y equals -1, z equals 2. Because the rest are all zeros, and all those terms disappear. So 1 with x, 1 in the middle is with y, and the last one is with z. Can I stop the recording? Is that enough, what you needed?
Yes, that's good. Thank you.
Thank you. Good. Other questions? Okay, so I would like to start. We're not going to be able to finish, I don't think, but I'd like to start the systems of non-linear equations in 2 variables. We're not going to look at non-linear with 3. So only section 5.4, systems of non-linear equations in 2 variables. Again, substitution and elimination, the same idea, but these require a little bit more thinking, I would say. Not difficult. So let me choose the first example. X minus y equals -1, and y equals x squared plus 1. Any suggestions? It's already set for what we want to do. What do you think I should do? I'm told that y is this. So what do you think we should do?
Replace y in the first one with
Of
when it
course,
equals.
of course. Careful with the minus in front. So x minus x squared minus 1 equals -1. So this negative symbol has to be distributed. -1 has to be distributed to both terms. So, or you write parentheses and then distribute. So x minus x squared minus 1 equals -1. When we add 1 to both sides, 1 disappears. -x squared plus x equals 0. We multiply both sides by -1. I always kindly ask my students, refuse to solve an equation with a negative leading coefficient. It's so elegant and easy to eliminate that. Okay, how will I solve this equation and how many solutions will I get? What would you recommend? We've done this many, many times before. How will I solve this?
Add x to both sides.
Careful, it's quadratic. We want
So
to
you
see,
have to factor.
yes, and we will factor out x and what is left in parentheses.
-1.
Indeed. So how many solutions are we going to get here?
2.
Exactly. 0 from here and 1 from here. So notice now that we obtained 2 ordered pairs. One with an x being 0 and the other one with x being 1. This is good, but it's not good enough. I have to find y. When I plug in 0, 0 plus 1 is 1. When I plug in 1, 1 plus 1 is 2. So this system of non-linear, this is linear, but this is not linear. This is quadratic. This system of non-linear equations has 2 solutions. Do they work? I don't know. It takes a blink to check. So 0 for x, 1 for y. 0 for x, 1 for y. A 0 minus 1 is -1. Yes. 0 plus 1 is 1. Yes. Yes. Now I'm checking 1, 2. So 1, 2. 1, 2. 1 plus 1 is 2. 1 minus 2 is -1. Yes. This is the difference. This is the main difference between linear with two equations and nonlinear with two variables, I meant to say. Linear with two variables and nonlinear with two variables. This could have never happened in linear. It's not possible. It's either one, none, or infinite. But these were linear. For nonlinear, anything can happen. Okay, let's work on another. Let's say x squared plus y squared equals 5, and 3x minus y equals 5. One thing is for sure. In this example, we cannot use elimination. They are not the same variables. Even if you try to multiply, elimination does not work here. Substitution is the only option. And now we have to think